Transformations: horizontal compression or stretch, and horizontal shifts. You have to maintain a culture of transformation and stay true to your values. Jeff Weiner. Question 1. The graph of function f is used to obtain the graph of function g. A. Make a table of values for f and g. Parent function and transformation tables are constructed as follows. For the parent function, x equals 0, y equals 0, x equals 5, y equals 5, x equals negative 5, y equals 5. For the transformation, x equals 0, y equals 0, x equals 1, y equals 5, x equals negative 1, and y equals 5. Y parent is equal to y transformation. X transformation is equal to 1/5 times x parent. X transformation is equal to x parent divided by 5. To create the same output for the parent and transformation function, every x of the transformation must equal the quotient of x parent and 5. B. The graph of g is a horizontal compression of the graph of f by a factor of 5. C. The slope of the graph of function f, slope is equal to rise over run, which is, for this case, 1 over 1, as seen on the graph, rise over run, which equals 1. The equation of the function f is f of x equals absolute value of x. The slope of the graph of function g, similarly, slope is equal to rise over run, rise 5 units, run 1 unit. Thus the slope is 5. And the equation of the function g, g of x, equals absolute value of 5x. Part D. Write an equation for g in terms of f. G of x is equal to f of 5x. When we multiply a function's input by a positive constant, we get a function whose graph is stretched or compressed horizontally in relation to the graph of the original function. Consider the function f of x equals x squared. The graph of g of x of the quantity 0.5x everything squared is a horizontal stretch of the graph of the function f by a factor of 2. Indeed, g of x transformation equals the quantity 0.5 times x transformation everything squared. 0.5 x transformation is x parent, which is equivalent to, after multiplying both sides of the equation by 2, x transformation is equal to 2 times x parent. To create the same output for the parent and transformation function, every x of the transformation must equal the product of x parent and 2. The graph of h of x equals the quantity 2x squared is a horizontal compression of the graph of the function f by a factor of 2. Indeed, h of x transformation equals the quantity 2x transformation everything squared. X parent is equal to 2x transformation. Divide both sides of the equation by 2. Equivalent to x transformation equals x parent divided by 2. To create the same output for the parent and transformation function, every x of the transformation must be equal to the quotient of x parent and 2. Generalization. Given a function f of x, a new function g of x equals f of b of x, where b is a constant, is a horizontal stretch or compression of the function f of x. If b is greater than 1, then the graph will be compressed by a factor of b. Example, g of x equals f of 3 of x. G is a horizontal compression of f by a factor of 3. X parent is equal to 3x transformation, which is equivalent to x transformation equals 1/3 x parent. If b belongs to the open interval 0, 1, then the graph will be stretched by a factor of 1 over b. Example, g of x equals f of 1/3 x. G is a horizontal stretch of f by a factor of 3. X parent is equal to 1/3 x transformation, which is equivalent to x transformation equals 3 times x parent. G of x transformation equals f of x parent. The y values are the same. If b is less than 0, then the graph will be reflected over the y-axis, or ROY. Question 2. Relate the function g to f. The graph of g looks like the graph of f horizontally compressed. Because f ends at point of coordinates 6, 4, and g ends at point of coordinates 2, 4. We can see that the x values have been compressed by a factor of 3, because 6 divided by 3 equals 2. We might notice that g of 2 equals f of 6, and g of 1 equals f of 3. We can describe this relationship as g of x equals f of 3x. This is a horizontal compression by a factor of 3. X transformation equals 1/3 x parent. Y transformation equals y parent. The graph of a function and two transformations are shown. F of x, and then to the right f of 0.5x, and to the left f of 2x. A horizontal stretch, f of 0.5x, moves the graph away from the y-axis. A horizontal compression, f of 2x, squeezes the graph towards the y-axis. Give the coordinates of the transformation. Point of coordinates 1, 5, horizontal stretch by a factor of 3. Thus, x transformation equals 3 times x parent. Therefore, x transformation equals 3 times 1. X transformation equals 3. Y transformation equals y parent. A horizontal stretch or compress does not change the value of y. Thus, y transformation is equal to 5. Therefore, point of coordinates 3, 5 belongs to the graph of the transformation. Point of coordinates negative 12, 5. Horizontal compression by a factor of 3. Thus, x transformation equals x parent divided by 3. Therefore, x transformation equals negative 12 divided by 3. Thus, x transformation equals negative 4. Y transformation equals y parent, since the horizontal stretch or compress does not change the value of y. Thus, y transformation is equal to 5. And the point of coordinates negative 4, 5 belongs to the graph of the transformation. Point of coordinates negative 12, 5. Horizontal compression by a factor of 3. Horizontal shift to the right 3 units. Thus, x parent divided by 3. From that, therefore, x transformation equals x parent divided by 3 plus 3. Or x transformation equals 1/3 x parent plus 3. Thus, x transformation equals negative 12 divided by 3 positive 3, which equals negative 4 positive 3. Thus, x transformation is equal to negative 1. A horizontal shift, compress, or stretch doesn't change the y coordinate. So y transformation equals y parent. Thus, point of coordinates negative 1, 5 belongs to the graph of the transformation. Point of coordinates negative 12, 5. Horizontal shift to the right 3 units. Horizontal compression by a factor of 3. A shift is x parent plus 3. Thus, x transformation equals the quantity x parent plus 3, everything divided by 3. Or x transformation equals 1/3 times the quantity x parent plus 3. Thus, x transformation is equal to the quantity negative 12 positive 3, everything divided by 3, which is equal to negative 9 divided by 3. Thus, x transformation is equal to negative 3. Y transformation equals yp, because, as we know, a horizontal stretch, shift, or compress does not change the y. Thus, point of coordinates negative 3, 5 belongs to the graph of the transformation. Important. The order in which transformations are performed matters. A shift followed by a compression or a stretch is not the same as a compression or stretch followed by a shift. In order to describe a horizontal transformation, we must have an equation for the x transformation. If g of x equals a times f of b times the quantity x minus h, close parentheses, everything plus k, then x parent equals b times the quantity x transformation minus x. The argument of the parent must equal the argument of the transformation. Equivalent to x transformation equals 1 over b times x parent positive h. If g of x equals a times f of bx plus c, everything plus d, then x parent equals bxt plus c. The argument of the parent must equal the argument of the transformation. Equivalent to x transformation equals 1 over b x parent minus c over b. Describe the transformations. Y is equal to f of x. G of x equals f of 8x plus 3. G of x transformation equals f of 8x transformation plus 3. The argument of the transformation must equal the argument of the parent. X parent equals 8x transformation plus 3, which is equivalent to 8x transformation equals x parent negative 3. Divide both sides of the equation by 8. Equivalent to x transformation equals 1 over 8x parent minus 3 over 8. The transformation is a horizontal compression by a factor of 8, followed by a horizontal shift to the left of 3/8 units. Or x transformation equals 1 over 8 times the quantity x parent minus 3. The transformation is a horizontal shift to the left 3 units, followed by a horizontal compression by a factor of 8. Question 8. Y equals f of x. G of x equals f of 8 times the quantity x plus 3. G of x transformation equals f of 8 times the quantity x transformation plus 3. The argument of the transformation must equal the argument of the parent. Xp is thus equal to 8 times the quantity x transformation plus 3. Divide both sides of the equation by 8. Equivalent to x transformation plus 3 equals 1 over 8 x parent, which is equivalent to x transformation equals 1 over 8 x parent negative 3. The transformation is a horizontal compression by a factor of 8, followed by a horizontal shift to the left 3 units. Or x transformation equals 1 over 8 times the quantity xp minus 24. The transformation is a horizontal shift to the left 24 units, followed by a horizontal compression by a factor of 8. Question 9. Y equals f of x. G of x equals f of 0.5 times the quantity x plus 3. G of x transformation equals f of 0.5 times the quantity x transformation plus 3. The argument of the transformation must equal the argument of the parent. X parent is equal to 0.5 times the quantity x transformation plus 3. Multiply both sides of the equation by 2, equivalent to x transformation plus 3 equals 2x parent. Equivalent to x transformation equals 2x parent minus 3. The transformation is a horizontal stretch by a factor of 2, followed by a horizontal shift to the left 3 units. Or we could write it as x transformation equals 2 times the quantity x parent negative 1.5. The transformation is a horizontal shift 1.5 units to the left, followed by a horizontal stretch by a factor of 2. Question 10. Fill in the tables below. According to the table, f of negative x equals f of x. Thus, if the point xy belongs to the graph of the function f, then the point negative xy belongs to the graph of f of negative x. Thus, on the right table, when x is equal to negative 4, y equals 1, x equals 1 when y equals 5, and x equals negative 3 when y equals negative 4.
The graph of y equals f of negative x is a reflection over the y-axis of the graph of function f. Indeed, the point of coordinates 4, 1 is reflected over the y-axis into the point of coordinates negative 4, 1. The point of coordinates negative 1, 5 is reflected over the y-axis into the point 1, 5. The point of coordinates 3, negative 4 is reflected over the y-axis into the point negative 3, negative 4. The points on the graph of the transformation are a reflection over the y-axis of the points on the graph of function f. In conclusion, the graph of the transformation f of negative x is a Roy reflection over the y-axis of the graph of the function f. Important: if y equals f of x is increasing over open interval ab, then the transformation y equals f of negative x is decreasing over open interval negative b, negative a. If y equals f of x is decreasing over open interval ab, then the transformation y equals f of negative x is increasing over open interval negative b, negative a.
Extensions. If y equals f of x is the parent function, and y equals f of b times the quantity x minus h is a transformation, then if b is greater than 1, then the graph of the transformation is a horizontal compress by a factor of b. If 0 less than or equal to b less than or equal to 1, then the graph of the transformation is a horizontal stretch by a factor of 1 over b. If b is less than 0, then the graph of the transformation is a Roy. If y equals f of x is the parent function and y equals f of b times x minus h is a transformation, then if b is less than 0 and f is increasing, then the transformation is decreasing and vice versa. If b is greater than 0 and f is increasing, then the transformation is increasing and vice versa. Question 11. Suppose the x-intercepts of the graph of y equals f of x are at negative 4 and 2. What are the x-intercepts of the graph of y equals f of 2 times the quantity x minus 3? G of x transformation equals f of 2 times the quantity x transformation minus 3. The argument of the parent must equal the argument of the transformation. X parent equals 2 times the quantity x transformation minus 3. Multiply both sides of the equation by 0.5. Equivalent to x transformation negative 3 equals 0.5 x parent, which is equivalent to x transformation equals 0.5 x parent plus 3. The x-intercepts of the parent function are at negative 4 and 2. Thus, the x-intercepts of the transformation are 0.5 times negative 4, positive 3, which equals negative 2, positive 3, which equals 1. And 0.5 times 2, positive 3, which equals 1, positive 3, equals 4. The x-intercepts of the transformation are the points of coordinates 1, 0 and 4, 0. Question 12. Suppose that the function y equals f of x is decreasing on the open interval negative 4, 12. Over what interval is the graph of y equals f of 4 times the quantity x minus 1 decreasing? G of x transformation equals f of 4 times x transformation negative 1. The argument of the transformation must equal the argument of the parent function. X parent equals 4 times the quantity x transformation minus 1, which is equivalent to x transformation equals 1/4 x parent plus 1. F is decreasing on open interval -4, 12. Thus, -4 less or equal to x parent less or equal to 12. Multiply this inequality by 1/4, equivalent to -1 less or equal to 1/4 x parent less or equal to 3. Add 1 on all three sides of the double inequality. Thus, since 1/4 x parent plus 1 is equal to xt, this is equivalent to 0 less than or equal to x transformation less or equal to 4. The transformation y equals f of 4 times the quantity x minus 1 is decreasing on open interval 0, 4.
Question 13. True or false? If the function y equals f of x is increasing on the open interval -2, 5, then the function y equals f of -2x, -3 is decreasing on open interval -4, -0.5. G of x transformation equals f of -2x transformation, -3. The argument of the transformation must equal the argument of the parent function. X parent is equal to -2x transformation, -3. Equivalent to x transformation equals -1/2 x parent, -3/2. F is increasing on the open interval -2, 5. Thus, -2 less than x parent less than 5. Multiply all sides of the double inequality by -1/2. Equivalent to 1 is greater than -1/2 x parent is greater than -5/2. Equivalent to adding -3/2 on all three sides of the double inequality. 1 minus 3/2 greater than -1/2 x, -3/2, greater than -5/2, and -3/2. -1/2 x, -3/2 is x transformation. Equivalent to -1/2 is greater than x transformation greater than -4. F is decreasing on open interval -4, -0.5 because a ROI changes the function from increasing to decreasing. This is a true statement.
Question 14. Describe the transformation. Let's look at the coordinates of some points on the graph of the parent function and the corresponding points on the graph of the transformation. Point of coordinates -4, 1. Then R, point of coordinates 1, 1. Point A of coordinates -2, 3. Point R of coordinates 2, 3. We notice that the y-coordinate of the corresponding points are the same and the x-coordinates are different. Thus, the transformation is a horizontal transformation. As a result, g of x equals f of b times the quantity x minus h. In order to describe the transformation, we must find an equation for the x transformation. The argument of the parent function must equal the argument of the transformation. X parent equals b times the quantity x transformation -h. This is a linear equation with 4 variables. To find the constants b and h, we will plug in x coordinates of points on the graph of f and the corresponding points on the transformation. -4 equals b times the quantity 1 minus h, and -2 equals b times the quantity 2 minus h. This is a system of equations with 2 variables. If we divide the first equation by the second equation, we will eliminate the variable b. Thus, after dividing them, we obtain 2 equals 1 negative h over 2 negative h. Thus, 4 minus 2h equals 1 minus h, equivalent to h equals 3. Substitute h equals 3 in the second equation. Thus, -2 equals b times the quantity 2 minus 3, Equivalent to negative b equals negative 2. Equivalent to b equals 2. Substitute b equals 2 into the equation of the transformation. The argument of the x parent must equal the argument of the transformation. So x parent is equal to 2 times the quantity x transformation, negative 3. Multiply both sides of the equation by 1/2. Equivalent to x transformation minus 3 equals 0.5 x parent. Equivalent to x transformation equals x parent divided by 2 plus 3. The graph of the transformation g is a horizontal compression by a factor of 2, followed by a horizontal shift 3 units to the right of the graph of the function f. Question 15. If the graph of g is a horizontal compression by a factor of 2, followed by a horizontal shift to the left 3 units of the graph of the function f of x equals 1 over x, what is the equation of the function g? Parent function, f of x parent equals 1 over x parent. The graph of g is a horizontal compression by a factor of 2. X parent divided by 2. Followed by a horizontal shift to the left 3 units of the graph of the function, negative 3. X transformation equals x parent divided by 2 minus 3. Solve the linear equation for x parent. Equivalent to x parent divided by 2 equals x transformation plus 3. Multiply both sides of the equation by 2. We obtain x parent equals 2 times the quantity x transformation plus 3. G of x transformation equals f of x parent. Thus, g of x transformation equals f of 2 times the quantity x transformation plus 3, which equals 1 over 2 times the quantity x transformation plus 3. The equation of the function g is g of x equals 1 over 2 times the quantity x plus 3. Question 16. If the graph of g is a horizontal shift 3 units to the right, followed by a horizontal stretch by a factor of 2 of the graph of the function f of x equals 3x squared plus 5, what is the equation of the function g? Parent function, f of x parent equals 3x parent squared plus 5. X parent plus 3 because of the horizontal shift 3 units to the right. The quantity multiplied by 2 because of the horizontal stretch by a factor of 2 equals x transformation. Solve the linear equation for x parent, divide both sides of the equation by 2. Equivalent to x parent plus 3 equals 1/2 x transformation, which is equivalent to x parent equals 1/2 x transformation minus 3. G of x transformation equals f of x parent. Thus, g of x transformation equals 3 times the quantity 1/2 x transformation minus 3, everything squared, plus 5. G of x equals 3 times the quantity 1/2 x minus 3, everything squared, plus 5. Question 17. True or false? If f of x equals negative 5x cubed plus 1, then the graph of g of x equals 40x cubed plus 1, is a reflection over the y-axis and a horizontal compression by a factor of 2 of the graph of the function f. Parent function, f of x parent equals negative 5x parent cubed plus 1, a reflection over the y-axis. To reflect over the y-axis, we multiply the x parent by negative 1, so we have negative x parent. And a horizontal compression by a factor of 2 of the graph of the function f, so we divide by 2, equals x transformation. Solve the linear equation for x parent. Multiply both sides of the equation by negative 2. X parent is thus equal to negative 2x transformation. G of x transformation equals f of x parent. Thus, g of x transformation equals negative 5 times the quantity negative 2x transformation, everything cubed plus 1. Thus, g of x equals 40x cubed plus 1. This statement is true. The end.